Okay, so this video might be a little longer than some of the others because there's a lot going on here. If you have already graphed your data into like a scatter plot on your coordinate grid, now you have to think about what kind of pattern the data looks like. So I'm gonna like zoom out a little bit, and that looks pretty exponential to me. So if yours also looks exponential, keep watching this video. If yours looks linear, then switch over to the video called How to Create a Line of Best Fit, or How to Create a Linear Model on a Scatter Plot. So this is not something that we've done in class, the one with the exponential function. We did the linear model in class. We did not do the exponential function in class, so this is something new. You're going to want a graphing calculator for this. Just like when we made our linear model, we had to pick a point kind of near the beginning and kind of near the end. And if you remember, we had to find the slope between those two lines and calculate the y-intercept so that we could write an equation for the line that went through most of the points. It's a similar thing with an exponential function, but we're going to use the calculator to help us do some of that heavy lifting. So I picked a point near the beginning down here, and I picked one near the end that would be on, like if I were to sketch kind of a curve here, those points would be on the curve that I'm going for. So I used my table that I had created earlier to figure out what those points actually were, and I wrote them down here for easy access. Okay, so I'm going to get out the calculator now, and I'm going to hit, oh, by the way, pause, rewind, like watch this as many times as you need to, because I might go kind of quickly. So I'm going to hit stat right here, and I'm going to hit enter because I'm already on the edit, option number 1, that's what I want. And I already have some data in these two lists, and I want to get rid of it. If your lists are empty, then that's fine. You don't have to do this step. So I'm going to like use my up arrow to go all the way up to where it says L2, and I'm going to clear that data and hit enter. And then I'll go over to list 1, clear that data, and hit enter as well. So now my lists are empty. And I'm going to put my first point, my x variable in list 1, and my y variable in list 2. So my first point is 10, enter, and go over to list 2, 134,053, enter. Okay, then my second point, I'm going to put also my x value is 90 in list 1, and my y value in list 2, 4,401,522. Oh, okay. So I'm kind of glad this happened. That number is too big to like fit in this little space, that 4 million number. So if you look carefully, you'll see that there's an E in there. So that wrote it as scientific notation. If I scroll up with my arrow button, it will display the full number down here, but just to make it fit in my table, it put it in scientific notation. So if you see that happen to yours, it's okay. Okay, so my next step is to get out of this. So second quit, I go back to my regular home screen, and then I'm going to hit stat again, and I'm going to go over to the right to get calc options. And depending on your calculator, you're going to have to scroll down a ways. On these TI-83 Plus, you want option number 0, which is EXP REG. That stands for exponential regression. Different calculators might have it like a 9 or A or something. So you just want the one that says EXP REG, exponential regression. And you're going to hit enter because you want that. So it says exp reg on your home screen. Okay, so your next, these are my notes actually, because I just learned how to do this today. Mr. Wilson taught me. Okay, so the next thing you're going to do is you want to tell it, like, so the calculator is saying, okay, you want me to find an exponential regression. but what am I going to find it of? Like, what are the values that I'm going to use to find my exponential formula, my regression? So you're going to tell it the values you want it to use. You're going to hit second, and then down here, you'll see L1, L2, L3. These are referencing those lists, and you put L1, your X data, into L1, so you're going to push that so it shows up L1. And then you're going to use the comma right here. It's over the 7, comma. And you're going to do second number 2 to make it say L2. So that's going to say, what is the exponential regression of L1, comma, L2? This is my X values. These are my Y values. And you're going to hit enter. And there you go. So this is saying that this is the form of the equation, a times b to the x. We've talked about that when we did our exponential unit. This is the a value. So this would be like your y-intercept or your initial value. On my particular graph, my numbers are how many years since 1915. So like my y-axis actually represents the year 1915. So this is saying that in 1915, there were, according to this model, there were 86,643 visitors to the park. I don't know if that's true or not. Actually, I don't even think the park was open in 1915, but I can look at my graph, and 86,000 is much less than 200,000, so it seems reasonable. Okay, and then this is my growth factor. Remember that B is the growth factor. So 1.04, blah, 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 blah. That's my growth factor. So you are going to want to write that down off to the side, that your equation is y equals whatever. And you want to get as exact as you can. I mean, these numbers are kind of long, so I'm going to go for 5, 2. So this is my A times, let me move this over, A times B, that's my growth factor. I'm going to say 1.0446 to the x. So that's the equation. Remember, y equals A times B to the x. Here's the A, here's the B. So I just wrote that in so that I can make a prediction next. So I'm going to type in my formula, 86643.452 times 1.0446 to the, and then we want you to extrapolate how many visitors you could expect, predict how many visitors you could expect 20 years from the most recent data that you have. So my most recent data on my graph, at least, is up to 100 years after 1915. So this data is for 2015. So 20 years after that would be 120 years after 1915. So I'm going forward in time 20 years after the last piece of data that I have on my graph. Ooh. Actually, it looks like the last piece of data on my graph is from 95 years after. So 20 more years would be 115. So I want to know, now I'm going to put 115 as my exponent. So that is how many visitors, if the current rate continues, that's how many visitors would be expected 20 years after my last piece of data. My last piece of data is from 2000, when was it? 90 years, sorry. So my last piece of data was from 2005. 20 years later, it would be 2025. And in 2025, supposedly there will be 1309146 I'm going to make it a whole number of visitors and forget the decimal. 123, comma, 123, comma. So 13,091,464 visitors expected in the year 2025, a generation after the last piece of data that I have on my graph.